Hello everyone, and in this video, we're going to be solving a problem that appeared on the TST for Iran. Here's how it goes. So suppose you have a triangle ABC, and M is the midpoint of BC. And then E and F are the feet of the altitudes from B and C to AC and AB, in that order. So CF is perpendicular to AB, and BE is perpendicular to AC. And then we construct the midpoints P and Q of FM and ME. And then we let this intersect the line parallel to BC going through A, so this line here, and these lines intersect at a point X. And what we want to prove is that AX is equal to AM. So how would we go about doing this? Well, we have that there's a line connecting the midpoints. So if we were to just do angle chasing, that wouldn't really work because we want to somehow use the fact that these are midpoints. So what do we do? Well, recall from a past video that I made that if we draw the circumcircle of this triangle, it ends up being tangent to MF, ME, and AX, which are all in the figure. So we definitely want to use this somehow. Well, since AX is tangent, we might want to start thinking power of a point. So AX squared, we want to prove that is equal to XM squared. So we want to prove that XM squared is a power with respect to some circle, and that PQ is the radical axis. Recall from my last video that radical axis is just the line where all the powers are the same. And it's a line as I showed in the last video. So given this, we want to find another circle that has a radical axis. This has a radical axis, this red line. And then it has its other pair circled, the circumcircle of AEF. And the power of x with respect to this circle was m. So we want to find a circle omega such that power with respect to omega of x is equal to xm squared, and then pq is the radical axis of the circumcircle of AEF and omega 2. So what haven't we used yet? Well, we haven't used the fact that MF and ME are tangent to the circumcircle. So maybe we could list something related to the power of P, because P is on the radical axis. The power of P with respect to this circumcircle here is just PF squared, and we know that's equal to PM squared here. And similarly, the power with respect to Q is QM squared. And these must be the powers with respect to this new circle. So we have a PM squared, a QM squared, and an XM squared. And all of these lines can't possibly be tangent to a circle, right? At the same point, M. So what do we do? Well, we remember our formula for power of a point, which is like distance squared minus r squared. And these look a lot like distance squared. So what happens if r equals 0? That might be worth a try. Let's go ahead and see what happens. So let me go ahead and clear all this stuff. So we can suppose that omega 2 is just equal to the dot m, radius 0, right here. And we want to prove that x lies on the radical axis of these two circles, omega 2 and this circumcircle, as that would imply that ax squared, which is the power with respect to this circle since xa is a tangent, is equal to xm squared since that is a power with respect to omega 2 because m is just a dot. In other words, we want to prove that PQ is a radical axis. But we already did this. We note that pf squared is equal to pm squared, and qe squared is equal to qm squared. So we are done. This problem ends up being surprisingly easy knowing these circumcircle tangents here, and also the fact that x must lie on some radical axis, where the power of p, q, and x with respect to this new circle here end up being pm squared, qm squared, and xm squared. And then we become a little fishy, and then we eventually come up with a circle of radius 0. So thank you so much for watching. Please subscribe if you enjoyed, and I'll see you in the next video.